Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the process concept in the process scheduling. First one, process. The process is that is program in execution. Here we have the multiple parts, that is stack, heap, text and the data. First one, stack. The process of stack contains the temporary data such methods are the function parameters and the return address and the local variables. Second one is heap. This is dynamically allocated memory to the process during its runtime. Third one is text. This includes the current activity represented by the value of the program counter and the content of the process's registers. Fourth one is data. This section contains the global and the static variables. Second one, process state. The process states can be any of the following states. Here we have the five state, that is new, ready, running, terminated. Like this, we have the five states. First one, new. The process is then the state or stage of being created. That is the first stage, new state. Second one is ready. The process has all the resources available that it is needs to run, but the CPU is not currently working on this process instructions, that is ready state. Third one is running. The CPU is working on this process instruction, that is third state, running state. Fourth one is waiting state. The process cannot run at the moment because it is waiting for some resources to become available or for some event to occur, that is fourth state, waiting state. Fifth one is terminated. The process has completed, that is completion status, a terminated state. And here we have the diagrammatic representation of the process state. First one we have the new, then ready, and then admitted to ready, followed by this we are going for the running state, and then running state, and then a waiting state, and then terminated state. Next one, we have the process control block. There is a block control block for each process that enclosing all the information about the process. That is process control block is the data structures which contains the following. It contains a process state. It can be running or the waiting, etc. It contains the process ID and the parent process ID. Next one is CPU registers and the program counter. Program counter holds the address of the next instruction to be executed for that process. Second one is CPU scheduling informations such as priority informations and the pointers to scheduling the queues. Third one is memory management informations. Example, page tables or the segmented tables. Here we have that. Next one is accounting informations, user and the kernel CPU time consumed. Account numbers and the limiter, etc. are available in the accounting informations. Next one is input output status information. Here we contain the devices allocated and the open file tables, etc. The next one, that is PCP, is maintained for the process throughout its lifetime, and it's deleted once the process terminates. Here we have the diagrammatic representation for the process control block, that is PCP. Here we have the process state followed by the process number. Next one, program counter. Next, followed by this, we have the registers and then memory limits and the list of open files. Next one is process scheduling. Definition for the process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of the another process on the basis of particular strategy. Next one, scheduling queues. Scheduling queues refers to the queues of the process or the devices. When the process enters the system, then this process is put into one job queue. The queue consists of all the processes in the systems. The processes that are residing in the main memory and are ready and waiting to execute are kept on the list called the ready queue. This queue is generally stored in the linked list. The operating system also maintains other queues such as the device queue. Device queue is a queue for which multiple processes are waiting for the particular input-output device. Next one is the newly arrived process is put into the ready queue, followed by this process wait in the ready queue for allocating the CPU. Once the CPU is assigned to the process, then that process will execute. While executing the process, any one of the following event occurs. Next one, the process could issues an input-output request and then it would be placed in the input-output queue. The process could create the new sub-process and will wait for its termination. Here we have the queuing diagram for the process scheduling. Here we have the ready queue, CPU, input output, and input output queue followed by this input output devices. Thank you.